Thank you for joining us. Today, I, Panashe, Mabwe, and Pandelani, Nekhumbe will be taking you through our MIT808 capstone project. This is what we are going to be going through. We are going we are going to go through the case study overview, methodology, our results and discussion, and then just a brief demo of the actual web application. In terms of the case study, we worked with the Forestry and Agricultural Biotechnology Institute, and they needed assistance in identifying and classifying pests, starting with the Sirex, which is on the bottom left, the two images on the bottom left. On the left, that's the Sirex in its larva stage, and then after that, that's it in its adult stage. Then on the right, we have the Gonipterus pest. And the forest and agricultural sectors are vital for the country's economic growth and food security. However, the rapid industrialization has enabled the manifestation of pests, which hinders the produce of crops. Ultimately, pests destroy crops in various ways, and approximately 40% of crops fall to pest-related diseases, highlighting the devastating impacts that these pests have. In terms of data sets, the Institute provided us with a total of 182 images of the pests. The dataset was comprised of 142 images of the Gonipterus and 42 images of the Sirex pest. The limited dataset provided was inefficient in training a deep learning model. So to mitigate the constraint of the limited dataset provided, we utilized transfer learning techniques in the IP102 dataset, which is a publicly available dataset mainly made up of insects that are prevalent in Asia. The dataset contains more than 75,000 images belonging to 102 categories. And in the dataset, there are also 19,000 images that have that are anointed with bounding boxes. In terms of the data pre-processing, we started by annotating the images. We used an open source manual annotation software to indicate where the pests are in the image and what the class the pest belongs to, as depicted in the image on the bottom left. Furthermore, we applied transfer learning, where we used the knowledge obtained from other models that have been pre-trained on ImageNet and the IP102 dataset to classify the pests. I will now hand over to Pandelani, who's going to take us through the results of the models.
Thank you, Panashe. In terms of the results, I'll just give an overview on how training was done first. So training was done using various ResNet models and mobile net models as well. So we used models that were pre-trained on the ImageNet dataset and performed some sort of transfer learning using our specific dataset. The results that we obtained on both the IP102 and FABI dataset were impressive as well. On the IP102 dataset, the results that we got were even much better as compared to the results that were reported on the original paper. What we have managed to build is a backbone that can be used to build a proper detection algorithm using the best performing classifiers from either the mobile net or the ResNet models. In the next slide, I will discuss some of the challenges that we experienced while working on this project. The dataset that we got from FABI, as indicated by Panashe, was a very small data set, so we needed to do some sort of data augmentation to solve for that. And for most of the data set was unlabeled as well, so we needed to then create the bounding boxes annotations. And in the IP102 dataset, some images were taken in low light conditions. Some images had watermarks over them, so we needed to perform some sort of image enhancement techniques to solve for that. And then in the next slide, we then move to the demo. So I'll just switch my screens and get to the demo. Awesome. So the Streamlit app that we have created has multiple pages. The first page is the data analysis and exploration page, which allows one to upload an image and perform some sort of data analysis or processing techniques. So the image that we currently have uploaded here, it's Sirex at its lava stage, and you have the original image, and then you have the after image after performing the processing. So you can perform histogram equalization just to increase the contrast of the image, or you can add some blur effect as part of the data augmentation so that your model is able to learn insects in different lighting conditions. And then we also have another page that performs the classification, right? So you are able to upload an image of either the Sirex or Gonipterus, since our model is trained on those two insects. So if you upload, say, this image, you then get a prediction here to say, it's a Sirex. And indeed, it's a Sirex since we uploaded a Sirex image. And then you also have other models that you can choose from if you want to run a different classification model. And then the other page that we have shows the model performance of the trained models. So we have model performance of the mobile net on the FABI dataset, and we also have model performance on the IP102 dataset. The idea behind this page is to monitor the performance of the model over time, and also just have some triggers for retraining and continuous development. That's our application in a nutshell. Thank you.